Good afternoon, everyone, and welcome to this BCO Scotland NextGen event with Gardiner and Fieldwold on mass timber and its effect on cost and programme. My name is Neil Hemingway, BCO NextGen Scotland Chair, and it's my pleasure to host today's event. Building on the momentum of COP26, we are keen to bring a series of lectures that aim to arm us with information to promote new sustainable approaches to design, procurement, and development of buildings. Sustainability and achieving net zero is the driving force behind developer appetite in exploring mass timber / hybrid offices. This session will focus on cost, programme and procurement challenges and opportunities when building with mass timber. I'm delighted to be joined by two leading figures in the G&T Mass Timber Office Forum, Associate and Project Manager Jess Pennell and Project Surveyor Jack Lewis. Jess will kick off the session by highlighting the key drivers for successful programme delivery on mass timber builds. And Jack will follow, providing an insight into the cost implications of buildings with mass timber compared to other more traditional methods of construction. This presentation will be followed by a short Q&A session, so please fill in any questions into the Q&A tab at the bottom. So without further ado, it gives me great pleasure to welcome Jess for the first part of the presentation.
Thank you, Neil, and good afternoon, everyone, and welcome to the BCO Does Mass Timber in Office Construction. And today we're focusing on the cost and programme implications. Myself and my colleague Jack will take you through some of the key factors to think about whilst considering using mass timber in your office construction projects. During the design phase, there are some key drivers that have to be considered prior to making the decision to go with a mass timber solution. So why are we now considering mass timber? It's now being considered by developers more than ever as a result of an increased focus on sustainability aspects of construction, with one of the key drivers for this being embodied carbon and carbon offset requirements. Timber solutions are the only renewable building material, resulting in lower embodied carbon and can link to corporate and social responsibility aspirations of many businesses. This slide shows some of the key drivers, hopefully. Which I will now take you through a few examples of. Sustainability. Non-timber solutions now incur a carbon tax, which is supported by policies. Factors such as these are starting to drive towards low carbon and carbon neutral solutions. It is important to really consider what the project goals are for sustainability and how these link with local planning strategies and policies. This all closely links with health and well-being matters. Visual aesthetics of providing exposed timber elements, which can form part of achieving positive impacts on well-being and health. Improvements in technology and modern methods of construction have enabled timber solutions to become a more viable option, where for many years they have only been aspirational. The development of hybrid options enables some of the barriers to using entirely mass timber to be overcome, such as the performance in the event of a fire. It also helps to deal with the concerns that are raised by the insurance industry in regards to total loss of the structure and claims of such as a result of a fire, with the hybrid structure utilising steel, which is a more common building material. Also, the growing knowledge on mass timber solutions from research and testing in Europe and worldwide is informing engineering solutions, particularly with regard to fire engineering, all of which are assisting to help define whether timber is a suitable solution for your projects. We must also consider the intended use of the building, be it commercial, residential, educational, or retail, and the structure and form of the intended development. If the form is simple and has short spans, timber solutions are suitable and appropriate. However, if the building is more complex with larger spans, alternative solutions may be more appropriate to be considered. Considering each of these key drivers will enable you to conclude whether timber is the best and most appropriate solution for your project. The next step is selecting the project team. It's important to appoint a team of consultants with the right level of knowledge, competence, experience, and expertise to take forward a mass timber building, with key early appointments to include the architect, structure engineer, fire engineer, and building control.
Just on that point, are you finding that there's a premium for consultants fees in timber projects at the moment?
Thanks, Jack. We are sometimes finding that consultant fees can be higher in regard to timber projects. With the earlier involvement and engagement of key stakeholders, such as the fire brigade, and some more detailed coordination needed between fire and structure engineers, this can drive additional fees and also earlier expenditure of such fees. Part of building a team is to form a competent and experienced peer review group to complete reviews during the design process, to validate the designs, particularly in regards to fire and structure engineering. As we found during the Mass Timber Forum sessions last year, it's important to form these groups to assist with the building control process. And parties that can form such a peer review group can also be from academic areas as well as consultancy firms for both fire and structure. A key step is to engage with key stakeholders early in the process. Here is a key stakeholder diagram. As for every project, awareness of key stakeholders engaging early is key, but it's particularly key when considering mass timber as a frame solution for the project. And it's important to understand which stakeholders should be involved in the outset of the project. As shown on this diagram, these can range from the project design team members to governing bodies, regulators, insurers, to manufacturers, suppliers, forestry, and subcontractors, not forgetting the end users and also the public perceptions. The importance of early engagement with the local fire brigade, insurance brokers, and risk assessors should not be overlooked, and is particularly significant on timber projects. Moving into the design process, during the design phase, the consultants will need to consider and establish the extent of mass timber to be used. Will it be a full timber solution or a hybrid with steel frames and timber floors, for example? From my experience, it is necessary to undertake site surveys at the early design stages, particularly for cut and carve projects, to inform the design development and avoid problems later down the line. Design information and design freeze will be needed relatively early in the design process to undertake testing, engage with and obtain buy-in from key stakeholders, and for the negotiation of pre-construction services agreements with specialist timber subcontractors, which are key to help the design development of timber projects. Early selection and design of the cladding system is needed so that it is built into the design from the outset of the project. This may also need subcontractor input and therefore also needs to be procured under a direct design appointment leading to a PCSA. Following the process of early subcontractor design engagement will enable the piece count to be established early and ensure the size of components are identified such that they can be delivered to site in the most efficient way. This, alongside the lifting strategy, is key to the completion of the structure and achieving the most efficient construction duration. It is also important to ensure that the fire strategy is developed and correct for the use of the building, along with clearly defined structural tolerances with careful consideration of vibrations and movement as well as acoustics. It is key to consider the sizing of the floor panels to allow for the main structure to be on the correct grid and fit with the architectural design. Overall, mass timber lends itself to utilising BIM for both the design coordination and to enable the design for manufacture elements to assist with site logistics and construction programming.
Just on that and thinking about it a little bit more in depth, is it possible to develop the design without a PCSA and that early contractor involvement?
Of course, anything is always possible, but you do lose some of the efficiencies and benefits from early contractor involvement. You may also need to procure new team members with correct expertise and competence, and as I mentioned earlier, a peer review team. It's also important to have a design freeze and do this early so you can engage with the stakeholders and obtain buy-in and perform testing.
Well, thanks for that, Jess. Just moving now into the cost considerations, and in regards to talking about cost of timber frame buildings and how they can be efficiently and effectively delivered, I believe that it's important to take a step back and remember that the construction cost of every building that we're involved in is driven by a number of factors. And these factors boil down to the form, use, location, and the materiality. The interplay between those factors is what often drives in the method to what the building is most economically put together. So when I'm discussing the form of the building, it takes into account the height, the shape, the position of that building into consideration. However, this is then generally influenced by its use. And when we're talking about the use, I'm generally talking in regards to whether the building is an office or a school or a residential dwelling. And then from this, you may want to then think about its location. Can I easily build this scheme because it has a readily accessible site? Or is it in a remote location trying to build an office on an island? Bringing this all together influences the materiality. The form, location, and its use leads us to a solution or a series of material solutions where we can look at what is the most economic. Adding to this, there's a further series of factors which also need to be explored and thought about, which Jess has touched on earlier, such as aesthetics, carbon and sustainable considerations from all viewpoints, such as economics, social, and environmental, like in the likes of well-being, as this is becoming an increasingly important factor. And lastly, there is your choice. The choice point has been recently included engineered mass timber, as this has become widely and commercially available within the UK, with the ability to perform more like a concrete or steel frame. When considering an office building, it may typically have a cost distribution of the cost proportions which are shown within this diagram. Of course, the cost will vary in every building, and it will be influenced by the four previous points: form, use, location, and materiality. But this is where the use of the structure can have an influence on the building, such as when we're utilizing a timber frame as your solution, it'll typically be lighter than other traditional options. Therefore, this will lead to a reduction in the foundations required for the building, meaning that there is a cost saving to be held there. And then just thinking about that, Jess, do you believe that there could be a program saving in regards to utilizing this timber building?
Yes, when thinking about program savings, you might not really find any savings in the frame construction, as it's much like a steel frame build. However, with the reduction in foundations that you've just mentioned, from the lighter build, we would expect to see some less time in the ground and therefore some savings in the program there.
Perfect. So that has a knock-on effect to the overall cost of the project. And then furthermore on this point, the final finish can be influenced by its structure too. So if utilising a mass timber frame, there's an opportunity to leave that timber exposed, therefore not having to apply the finishes to the ceilings and internal walls. However, this is subject to the fire and spread of flame details that are required for that construction. In this example, approximately 20% of the cost of the building is in the frame. And now I'm going to go and show you some relative costs of some different framing solutions. So every building will need to be considered on its own merits, and many of the engineers that we work with, and they potentially could be on the call today, say that anything is possible, but that is definitely going to come at a cost. Typically, you generally say that a steel frame might be more cost efficient over a longer span in comparison to concrete. However, you could see a small premium in that, but that is dependent upon its market conditions, the steel prices currently, contractor choice, and the regularity of the grid that is proposed. And in this example of a typical 9x9 grid or 7.5 by 12 meter office grid building, you can see that the reinforced concrete rate might sit in a range of £300 to £325 per square meter in London. And then within Scotland, we'd expect to sit between £260 to £290 per square meter of gross internal floor area. Moving then on to the steel and hollow rib solution, again, you typically see in London a £325 to £350 per square meter, and then in Scotland a £290 to £320 per square meter. This shows that there isn't a huge amount of difference between the solutions depending on its location. I would like to add here though that the models include a concrete core for all the buildings, and the stairs are also part of the cost. Costs will change for other methods in this sort of range, such as PT flat slabs, which would again be more expensive. Moving on to the mass timber components and adding them into your cost ranges. Introducing a CRT slab would definitely be a premium over a concrete or a hollow rib slab, and it'd move the cost range to £350 to £420 per square metre in London and £320 to £400 per square metre in Scotland. Overall, this would equate to about a 20% premium for this solution. Moving to the right again, we now on to a whole timber building. So this is utilising CRT slabs with glulam columns and beams. This moves the cost up again another step. So in London, we'd expect that to be in the range of £420 to £475 per square metre. And in Scotland, £400 to £450 per square metre. In round terms, we're talking about a 50% premium over a traditional build. And then lastly, utilising the introduction of a laminated veneer lumber, so LVL, which is a hardwood mainly utilised in the columns and beams for its smaller profile, protecting the net area for the clients. This moves the cost on significantly again, costing in the range of £475 per square metre, £475 to £550 per square metre in London, and in Scotland, £450 to £500 per square metre, equivalent to a 70% premium. Overall, when you look at just the frame and solutions themselves, there's some quite significant variances in them, and there is a premium to play with in timber. However, when you put that into context of a building as a whole, the differential is a lot less than marked, as you can see in front of you. I just want to highlight here at this point now that the graph in front of you is based on the Scotland frame rates and is now expressed in cost per square foot. Importantly, when looking at these costs, if you add in the potential benefits from the reduction of foundation, the potential for the less interior finishes by expressing the timber as you'll finish, where possible, of course, and then couple that with the potential to be quicker in the on-site phase, that differential may well get closer in the overall project cost term than what is shown here, as they are not currently taken. Now, looking more specifically at some of the key elements of the building that can be influenced from a mass timber frame, and some of our assumptions that the typical cost ranges are based upon, I'd like to highlight the first one being acoustics. So acoustics within a mass timber building could be discussed into two sections. So you have impact noise, the transfer of noise between the slabs, and noise banks, which was where the noise will bounce around your building. When utilising a mass timber building, the potential cost uplifts which you may not think about would be the utilisation of a screed to help reduce that impact noise, or an acoustic raised floor with pads underneath the pedestals, or even an acoustic mineral wall or dense board, all again laid across the floor to help mitigate that impact noise. Then within the ceilings, you might want to consider acoustic ceiling baffle. This to help dampen the noise in the noisy areas, such as receptions, meeting rooms, and all your net internal lettable areas, as this will then stop your noise bounce around the building. We believe that the importance of getting a competent acoustician on board early will help raise and mitigate all of these issues through the design stages and hopefully mitigate the costs of that too. This next point I'd like to start talking about is the MEP. Early consideration in regards to the MEP layouts is crucial within a mass timber building. And this is because as soon as the material has been manufactured and cut using its CNC machine, making any retrospective changes will be time consuming and costly. Therefore, the fixing the MEP layout early is crucial and could be worth thinking about future flexibility here also by designing and cutting notches into those beams at predetermined locations to try and help mitigate this as much as possible. However, the number of notches that can be made are limited to ensure that the beam's strength and integrity are not undermined in performing its sole use for the building and keeping it up. Thinking about this, utilizing a hybrid approach such as steel and CRT, this could help mitigate these issues of making retrospective changes once you're on site, as the castellated beams provide far greater level of flexibility in comparison to using your glulam or your LVL as your beams within the building. In regards to fixing that all the MEP systems, it is very much like massive pattracing, and therefore there should be minimal issues once you're on site and start fixing that in. Overall, coordinating the frame design and putting together a considered and detailed MEP strategy early is key for cost efficiency. Another reason for us to potentially utilize and adopt BIM as much as possible with the class detection to help the mitigation of these issues. The next point I want to raise is on the frame. And as previously mentioned, when thinking about the frame of the building, the utilization of the LVL over glulam for beams and columns will come at a cost. However, in regards to the area of the building, due to the higher strength of that LVL in comparison to glulam, the profile of the material is smaller, achieving those greater spans at smaller profiles and therefore giving that net area back to the client. In regards to floor slabs, CRT floor slabs are typically 200 mm thick, subject to its grid layout and spans, and generally utilizing the CRT floor slab will be between 10 to 20% more expensive than its in situ concrete equivalent. On top of this, you may want to take into account visual grades and fireproofing costs that may need to be added dependent upon your design. Thinking more holistically about the frame, one factor you might want to think about is making it as logistically efficient as possible for transportation. The most efficient size that we have found for CRT panels are 2.95 meters wide and roughly between 13 to 16 meters long. And this is based on the articulated lorry dimensions. If you start going over these sizes, escorted loads will be required, which would then come at a cost premium. When thinking about early in the design, this can be then mitigated and designed out, saving money on these logistical costs. So bringing that to a head, we've covered quite a lot of information here in just a short amount of time in regards to mass timber frames and how best to logically think about utilizing mass timber in your building and how cost can be influenced by your frame choice. The factors here today are literally only the tip of the iceberg, with many other factors that can influence costs, such as fire encapsulation, prelims, chain of custody for sustainability, water ingress, and the grade of visual qualities for the timber, which should all be researched and thought about early within your design process to understand the true cost of the building. If you'd like to learn more about these factors, we at G&T have run a forum over the period of a year with panel sessions from experts in their field to discuss things such as insurance or fire in regards to mass timber. If this is of interest to you, please don't hesitate to get in touch, or you can find it within our website. And thank you for listening to us today. If you have any questions, we'd love to hear from you.
Brilliant. Thank you, Jess and Jack. That's a really fascinating introduction and insight into mass timber, especially the challenges and opportunities we have for kind of future adoption. We have already had a few questions come through into the Q&A tab, which, if it's okay, I'm just going to ask the first question which has come in. How does timber compare to other construction materials from an embodied carbon perspective?
I'll take this one. So although this is not generally our area of expertise, from the experience that I've had and working with the architects that have been calculating these and structural engineers that have also calculated these live calculations, I guess, you'd typically expect to see a timber solution around 10 to 20% lower than a concrete solution in terms of kilograms to CO2 equivalents gross per square meter. However, that it could be semi-misleading because the sequestration process from trees is not currently being taken into account. So if you start taking that process into account in that calculation, you could probably see that a timber solution be anywhere in the range of 50 to 70% lower than its concrete counterpart in that area.
Okay, and the second question that we've had in is to do with insurance, which I appreciate is probably quite a hot topic for everyone on this call, especially when we're looking at timber solutions. But the question is, we have found it hard to get insurance during and after construction. Have you found this as well?
I think I'll take this one. That's okay, Jack. So we're obviously not insurers, so we're not necessarily best placed to advise on insurance. However, on the projects that we've been working on, we have been in discussions with insurers at the early stages, as I mentioned in my part of the presentation. And we are aware that the key insurance experts and stakeholders from the construction industry have got together in a forum and a focus group to try and unlock this barrier. We have discussed insurance in more depth with the experts from the field on our mass timber forum session with the insurance and brokers, discussing risk, pricing, guidance and opportunities, this, as Jack mentioned, can also be found on our website. So please get in touch if you'd like to find out a bit more about that.
Brilliant. Yeah, and I mean, I had a quick look at the G&T Mass Timber Forum, which I would strongly recommend anyone on this call to have a look at. There's a brilliant YouTube channel, which I think hopefully the link will maybe pop into the chat just now, where there's a lot of these topics to do with insurance, fire, costing program, etc., where there's a lot of conversation about each of these key topics in relation to mass timber, and a very useful kind of thought leadership area. So yeah, there are a couple of other questions that have come in, which I think there's one which was on a specific building. I think that was shown in one of the early slides, the black and white building, and it's how lateral stability of the structure is going to be achieved. Appreciate this is possibly one is actually for the structural engineer on the call, so we'll maybe take that one away, and I'm sure there can be a kind of follow-up email to cover that question.
Just on that one, Neil, just in terms of that asks about an RC core with stairs and lift shafts. The building, black and white building itself, has a timber core, a mass timber core, and mass timber stairs. Just I hope that clears that clarification there for you, Jeff Taylor. But we'll follow up with an email afterwards in a little bit more depth for you as well.
Okay, and so yeah, I think that's all the questions that have come through just now. In fact, there's one other one that's come in just as we've been talking about MEP services coordination, which I think I'll ask the question, but it might be a case that this is a follow-up as well. With regards to MEP services coordination with timber frames, does there mean there's a limitation on whether it is suitable for Cat B fit out, or is it difficult to change later on?
I don't mind having a stab at it. I think ultimately, yeah, there is some difficulties in terms of retrospectively making those changes later on down the line, but as long as it's fixed within the predetermined notches, once you're into those bays, anything's pretty possible. Just as I said, as I mentioned, putting in the MEP systems into the mass timber is not a problem. It's just working around those beams and the columns to make your specified solution work.
Brilliant. Okay, so I think that's kind of our time for today. There'll be a recording of this session that will be shared from the BCO, and also hopefully everyone's made a copy of the links that have been shared into the chat. I would strongly recommend having a look at the YouTube channel in particular, where there's a lot more in-depth kind of discussions on some of the key points covered today. So I'd just like to conclude by extending a big thank you to Jess and Jack for sharing their knowledge. It's been a very, very interesting kind of initial introduction to mass timber, and hopefully it arms us with the kind of the information that we need to take away and promote use of timber within our future projects. And again, thank you for G&T supporting this event, and thank you for everyone for joining. Hopefully look forward to seeing you at the next session.
Cheers all.
Thanks everyone.
Thanks everyone.